In this video, we are going to discuss how to calculate the electromotive force EMF induced in a wire and how to find the direction of induced current. Question says, a straight wire is a part of a circuit that has a resistance R 0.50 ohm. A wire is 0.20 meter long and moves at a constant speed of 7 meter per second, perpendicular to the magnetic field of strength 8.0 times 10 to the power negative 2 Tesla. In part A of the question, they want you to find what EMF is induced in the wire, and in part B, we need to find the magnitude and direction of current through the wire. So let us first write down what the question has given us. We have the resistance R, which is 0.50 ohm. I have the length of the wire, 0.20 meter. We have the speed with which the wire moves, 7.0 meter per second. The strength of the magnetic field B, 8.0 times 10 to the power negative 2 Tesla. And the angle theta between the speed and magnetic field B, which is 90. When they say perpendicular, perpendicular means the angle theta is 90. So let's start with the first part of the question. In part A, we want to find electromotive force. Electromotive force or EMF is the potential difference that is induced in the wire. Do not confuse this word force with the force acting on a particle. Electromotive force is potential difference and not force. And the value of this potential difference is given as V L V sine theta. I will substitute my values here to calculate what is EMF. So we can write electromotive force equals B is the magnetic field strength, that is 8 times 10 to the power negative 2. L is the length of the wire, 0.20 meter. V is the speed, which is 7 into sine 90. And when you solve this, you get your EMF as 0.112 volt. Part B of the question wants me to find what is the induced current, what is the magnitude and direction of the current. Magnitude of the current can be calculated by using the basic rule of current, which is potential difference over R. My potential difference induced in the wire right now is the EMF. So I will rewrite this expression as EMF over R. Let's substitute. EMF is 0.112 divided by resistance, which is 0.50. And when you solve this, you get the magnitude of current as 0.224 ampere. This is the current that is induced in the wire. Now, how do we find the direction of the induced current? To find the direction of induced current, we use the right hand palm rule. To use the right hand palm rule, your fingers, your 4 fingers of the right hand must point in the direction of magnetic field. Your thumb will be in the direction of speed V, and the face of your palm will give you the direction of induced current. So let's try using a right hand palm rule to find the direction of induced current. Magnetic field here is pointing out of the page. The dot represent coming out of the page. And if you have cross, cross means going in. I will point my 4 fingers coming out of the screen. Speed is going to the right, So my thumb will be pointing to the right. And if you look at your right hand, your palm is facing down. So since your palm is facing down, that's the direction of current induced in the wire. So direction of current induced in the wire will be down, down on the wire. But if I were to find the direction of current through the entire circuit, I will trace the path the current goes. On the wire, it is going down like this, then it will move along the circuit in this manner, and this direction is counterclockwise. So through the entire circuit, the current is going counterclockwise. So this is how you can find the EMF induced in a wire, the current induced, and the direction of the current.